All right, so now we're going to be taking a look at a few questions, like application type questions. And we've seen these before, but we were taking the derivative, right? They were like physics style questions, but we kept on taking the derivative. But now we have this antiderivative tool. So now let's say if we start with a velocity function, we can work backwards and find our original displacement function, right? All right, so this one says a particle moves in a line such that its velocity is v is equal to t minus 3, where v is measured in meters per second. Find the displacement function if the particle starts at a displacement of 4 meters. All right, so we got to find our displacement function. And if you think about it in earlier units, if we started with our displacement, then the derivative of that displacement function was our velocity function. So we just really want to go in the other direction. So now we start with our velocity function, and we just need to find the antiderivative. All right, so if we start off with v is equal to t minus 3, then we'll say our displacement function is equal to 1 over 2, or maybe I'll back up. Let's do it one at a time. So it would be t to the power of 2, and then 1 over 2 goes in front. Okay, minus, and then this would be 3t, and then plus c. All right, so that is my displacement function. I'm just missing my starting point, right? But they did give us some, like an initial condition. They say that the particle starts at a displacement of 4 meters. So that's like a point, like we were doing in the last parts, right? But if it starts, that means we have a time of 0 and a distance of 4. So that's perfect because we can sub those things in now, right? So our distance was 4, so s is 4. That's equal to 1/2. Our time was 0 squared minus 3 times 0 plus c. So then we get 4 is equal to c. All right, so therefore our displacement function, so you can say s, or maybe s of t, is equal to 1/2 t squared minus 3t, and then plus 4. And we can check it out too, right? Like you guys could quite easily take the derivative of this and just check to make sure that it actually does give us our velocity function. All right, so now, how far does the particle travel in the first 5 seconds? Now, careful on this, just the wording of it. And if you've taken physics 20 and 30, you'll probably quickly know what I mean. When we found this was the displacement function, right? So if our particle, let's say our particle is like starting here, and then it goes and then comes back again in a straight line, then let's say it goes and then comes back again to here, right, in that straight line, our displacement function is only giving us the distance from here to here, right? Like that's how far, that's the number that would come out after 5 seconds, like if that was the case. But if the question, just kind of based on the way the question's worded here, how far does the particle travel in the first 5 seconds? I think that's implied that it means like the distance. So it would be like this distance, from here to here, plus this distance from here to here, right? So in order to do that, we need to figure out where it stopped and turned around, right? Hopefully that makes sense. So what we want to do now is we want to set v equal to 0 and then solve for t. So we can figure out when this time actually happened. Okay, so let's do that. So we'll say, so from v is equal to t minus 3, then we'll say 0 is equal to t minus 3. So then this happens at 3 seconds. You can also think of this as our critical numbers, right? Because this is where our derivative is equal to 0. Okay. All right, so let's get like a little bit of a picture of what's happening. So at time 0 for my displacement, so let's say like s of 0, that would happen at, so just based on our function here, if we threw 0 in there, we get 4, right? So here, let's make a little number line. So we're starting at 4, right? And then we know that, so we're starting here. So my picture is a little off here, just the directions, but so we're starting at 4, and then let's say at 3 seconds, right, when the velocity we know is 0. Then we're at, so if we plug all this in, we get negative 0.5. Okay, so if that's negative 1, we're going to come to here. So that's after 3 seconds. So we come from here to here. Comes to a stop, starts heading the other direction, obviously. Okay. And then at 5 seconds, if you plug all like 5 into our equation, we get 1.5 meters. So then we're going to be, so there's 1. Oh, my scale's kind of off. Okay. 1, 2, 3. Okay, so there's 1. So we're going to come to about there. All right, so if I want my total distance, right, then that's just going to be my 4 minus negative 0.5, just to get the distance, you know, my top red arrow there. Okay, and then plus this distance. Okay, so which is going to be just 1.5. So my total distance here would just be 6 meters.